And today we're going to start on page 92. We're covering two sections, 2.2 and 2.3. And the first section is over functions and graphs. Functions and graphs. And so what I'm going to do to lead off this section is something I don't think I've done yet this semester. I'm going to give a couple of definitions. First word. You need to know what the word relation means in math. So if somebody says, hey, I've got a relation, you'll know what they're talking about. A relation is a set of ordered pairs. A relation is simply a set of ordered pairs. So if any of y'all have ever been in a relation, you know what I'm talking about. Right? If you were ever a couple and you went out with some other couples, you were in a relation. Right? A bunch of X comma Y's, girl comma guys, you get it? Okay. And then we can talk about a function. A function is a relation. So you had to know what the word relation means. It's a relation in which each X can have only one Y. Only one Y. A relation is a function. A function is a relation in which each X can have only one Y. So in other words, if you want your relation to function, the X's had better be monogamous. The X's have to have only one Y. Notice what this does not say. Does this say each Y must have only one X? The Y's can have as many X's as they want, and it still functions, okay? But the X's have to be monogamous. Y'all understand that? Okay, now a couple more terms. You need to know what the word domain and the word range mean. You need to know those terms. And I'm going to give you the short definition. Is that okay? There you go. The domain are the X's, and the range are the Y's. And with that information, we can actually go and do a problem. And we're going to start with problem number 3 as soon as I make sure that I call roll. All right. Laura, Alyssa, Joshua, Hilaria, Hannah. Hey, where's Franklin? Sarah, Jackie, Mackenzie, Brenton, Kiana is here. Edson is here. Julia, Alex, and Julian. Gotcha. Number 3. All right, so what we have here for number 3, this is definitely a relation. Do Do you see it shows a relationship between the x's and the y's? It shows how the x's and the y's relate to each other. It's a relation. I want to know, is that a function? Yes or no? Okay, yes, it's a function. And does everybody understand why, looking at that, we can tell it's a function? It's because each element of the domain maps to only one element of the range. So the -5, does he go to anybody but 1? No, he only goes to 1. What about 5? Only goes to 1. 8 only goes to 1. And therefore, each x has only one y. But I want you to look at that 1. And that 1 is getting around. Yeah, he's like 3 timing. But that's okay for the y's to do that, okay? Y'all want to try another one? Okay, number 4. All right, is that a function? Who screws it up? Oh, 6 does. 6 is cheating.
So they don't necessarily have to go to the same number as long as they only go to one number.
Right, right. The thing that you got to remember is that each element of the domain is allowed to have how many lines coming off of them? Only 1. Because this shows 6 is going with 2 different y's, and that's not okay. Got it? Now, is that a relation? It is a relation because we could describe that as a set of ordered pairs, right? We could say 6, -6, 6, -7, 7, -7, 3, -3. We could write that as a set of ordered pairs. It is a relation. It's just not a function. And now do y'all think you've got that down? Okay, so we'll go to my next problem. And I'm going to call it my problem because they don't have one in the book like I want to do. So we're going to say A equals 0, -3, 3, 0, -5, 2, and let's go -2, 0. There we go. This is my problem. And I'm going to ask you a few questions, okay? I think about 4 questions for this one. First question. Is that a relation? In other words, is it a set of ordered pairs? Yes. So yes, it's a relation. Is it a function? I heard yes and no.
I say no because there's 2 y zeros.
There's 2 y zeros. So that means that 0 for y is with 2 different x's. And that's okay.
Okay.
Remember, the y's are allowed to be with more than one x.
Okay.
What you're not allowed to have is the same x going to more than one y. So what you can do to check and make sure is you can look at all of the x's and see if any of the x's are the same.
So the x's have to be
the same in order for it to not be a function. So are all of the x's different? Well, then it must be a function. And I don't know if you caught that, but that was good stuff right there I just said. If all of the x's are different, it must be a function. Because you have to have the same x repeated for it to be cheating. Now, next question. I would like for you to write the domain of this function. What's the domain? I'm ready. 0. There you go. And there's the domain. And I would also like the range. -3. Good. And you see I didn't write the 0 again because I already accounted for it. So if a number appears more than once, you don't have to write it repeatedly.
But if we do, is it okay?
If you do, I don't know. I may put a not happy face on there. I don't know if I'd count points off or not. Yeah, so if this is 0 and you see another 0, just remember I've already accounted for that. I don't have to write it again. And does anybody have any questions about any of that so far? Anybody? Okay, next new thing. Let's get some clean space here and let's go to number 19. Next new thing. Of x equals 2x squared minus 3x. And have y'all seen f of x before? Can you tell me what single letter does f of x represent? Good. You need to know that. So really this says y equals that stuff, right? But this, you also need to know that this is function notation for a reason. It's so that they can ask you questions like this. I would like you to find f of 0. And so what is that telling me to do? Right. So everywhere there's an x, I'm going to replace it with this number and then work it out. And you can use a calculator or you can do it mentally. What is that going to work out to be? A 0. So f of 0 is 0. Let's do another one. Let's try f of -1. Same process, same function. Now every x gets replaced with -1. And I'm going to need you to work that out and give me the answer. You can do it manually or electronically. 5?
Is it? No. I got 5.
You got 5?
Oh, okay. Is that not what we're supposed to do?
Oh, you put -3 up there.
Look what I wrote.
Oh, okay, so we're good.
I'm sorry, I wrote it down wrong. Now, you know what I could say? I could say I did that on purpose to see if you're paying attention. But really, the truth is I screwed it up. So if I write it down correctly, then I'm going to have to agree with 5. Whew, that was a good one. Any questions? All right, let's do another one. F of 4a. Let's do f of 4a. Now, what am I going to replace every x with? 4a. And now you're not going to get a single value. For an answer, you're going to get another expression. And do y'all remember your PEMDAS? Please excuse my dear Aunt Sally, order of operations. I'm going to have to do the exponent first before I can do the multiplication. So what is 4a squared? What is 4a times 4a? 16a squared. And 4 times 3, 12a. And then I can multiply 16 times 2, 32a squared minus 12a. And then at that point, can I combine 32a squared minus 12a? Can I go ahead and subtract those? Why not?
Because it's not the same.
Oh, they're not like terms. They don't have the same power. Yeah, so that's where we stop. And do y'all remember when maybe I haven't said this before, part of math is knowing when to stop, right? Sometimes you got to know, when do I stop? Y'all have any questions so far?
Can really elementary, can you explain to me why 4a is now 16a squared?
Yeah, I sure can. Because if you take 4a and square it, that means 4a times 4a. So 4 times 4 is where the 16.
Right.
And then a times a is where the a squared comes from. Okay, I'm not done. I got another part I want to do. Let's do f of a minus 4. This is going to be more exciting. Okay, so now what am I going to replace every x with? A minus 4. That'll be 2 times a minus 4 squared. Minus 3 times a minus 4. Every x gets replaced with a minus 4. And did y'all notice a minus 4 is a binomial? 2 terms. And if I square a binomial, what does that indicate? Oh, it's the 4-letter F word. Yeah. FOIL. So a minus 4 squared means a minus 4 times itself. And that's where FOIL comes from. The negative 3 can go ahead and distribute. Okay, and then we're going to have to F it up. Are y'all ready to FOIL it? All right, here we go. A times A. On the outside. Negative 4a on the inside. Another one just like it. Negative 4a. And last but not least, negative times a negative makes it a positive 16. Minus 3a plus 12 comes down. And now I can go ahead and distribute my 2. So that's going to be 2a squared minus 16a plus 32 minus 3a plus 12. And is everybody okay with where my minus 16a came from? Right there, that was a jump right there. Do y'all see where that came from? Everybody, not everybody shaking their head yet. Yeah, everybody see where that came from? Oh, watch this. 2 times 4 is 8. Oh, I got another one right here. 2 times 4 is 8. So negative 8a and negative 8a makes, yeah, so what I did is I combined like terms on the fly as I was going. And now I've got one more step and I'm done. 2a squared. I've got a minus 16a and a minus 3a. Minus 19a. I've got a plus 32 and a plus 12. And we're done. Isn't that fun? That's my favorite. I guarantee that'll be on a test. I love that stuff right there. Getting to foil it. But y'all already know what's going to be on the test, don't you? I did a review yesterday. Yeah. And are there any other questions on that particular problem? And do y'all understand what we just did is called evaluate a function? Evaluate the function is what we just did.
The last whole thing?
Yeah.
Okay.
All of this right here, number 19, all the parts. Evaluate. It means plug something in and work it out. And I've got a couple of more problems that we need to do from this section, and then we can move on. Number 51. And what number 51 wants is the domain. No, that's not what it wants. I'm so sorry. Losing my mind. Number 51, the instructions say, determine whether each of the following is the graph of a function. So this is a yes or no question. They want to know, is that graph a function or not? And the answer is yes, it is. Yes, that graph is a function. Does everybody understand why? It's because of the vertical line test. The vertical line test. Or I like to abbreviate the VLT. It's from the vertical line test. And what does the vertical line test say? It says if a vertical line touches more than one time, it's not a function. If a vertical line touches more than one time, it's not a function, okay? So can I draw a vertical line anywhere that would touch this graph more than one time? No, every vertical line that I could possibly draw will touch only once, right? And so that makes it a function. Next, number 55. There you go. And again, they want to know, is this the graph of a function? And does everybody see why this is a no? Is there anywhere that I could draw a vertical line that would touch more than one time? In fact, there's lots of places. What about right here? Touch, touch, right? Hey, listen, touching's allowed, but only once. Touching's allowed, but only once, okay? You touch too many times, not a function. That ain't going to function. And is that good for that? Everybody good? I appreciate you appreciating my jokes too. Now, let's move on to the next section. 2.3. And that's going to take us to page 99. Section, what did I do? I clicked the wrong thing. Delete. 2.3. And this section is specifically on domain and range. Domain and range. And I covered that already, what that means. The domain are and the range are the y's, okay? More specifically, the domain are the values that x can be, and the range of the values that y can be. And so if we look at number 4, they're going to give me a graph. -4 and 3. And 2 and -3. And for this picture, for this graph, they're going to ask you 4 questions. Ready? Okay. Part A. I would like you to find the domain of that graph. Yeah.
So is it still going, or is that like the input?
Exactly. Since these are not arrows, these are the endpoints. So it doesn't keep going. So the domain would be -4 to 2. Now the reason that's the answer is because as I move from left to right, where does the graph start existing? At -4? And does it continue to exist up until 2? And then what happens after 2? It ceases to exist, right? So from -4 to 2, the graph exists. And did y'all notice the domain moves from left to right? Now, range. You want to take another guess, Brennan?
I hope that's on -3 to +3.
Good. -3 to 3. And the reason that is the answer is because the range moves from bottom to top. So as I start scanning up from the bottom, do you see the graph starts existing at a height of -3? And does the graph continue to exist until I get up to a height of 3? And did y'all hear me say the range of the values that y can be? So these have to be y numbers. -3 to 3 on the y-axis, -4 to 2 on the x-axis for the domain. I hope y'all see that. I also hope you made a note of it that the domain is from left to right and the range is from bottom to top. Has to be. Part C. I would like you to find f of -2. What is f of -2? Okay, do you want me to explain how to find that? Okay. So, have y'all ever heard me say f of x?
Yes.
Okay. So normally where the -2 is, there would be a variable of x, right? But this time they're saying, hey, x is -2. What does f of x mean? Y. So this is like asking you a question that says, hey, when x is negative 2, what's y? When x is negative 2, what's y? Okay, so here's x is negative 2, and the y is how high? I'm thinking 2. F of negative 2 is 2. Does everybody see why? I'll do it again. If I go to negative 2 on the x-axis, then I'm going to go up until I hit the graph and see how high that is. So f of negative 2, the graph is up at 2. Okay? What about f of negative 4? That would be a 3. Okay? What about f of 0? That looks like about negative 1. About. You'd have to estimate that, okay? Y'all kind of see what I'm saying? So f of whatever says to go to that number on the x and then go up or down till you hit the graph and see how high that is. Part D. Okay, now let's ask it this way. F of x is negative 2 when x equals what?
0. So where does it hit on the y?
Okay, so when x is 0, we're at about negative 1. So we want to know
If y is negative 2.
y is negative 2. That's about what, 1.5, maybe, well, not 1.5, 0.5, maybe 0.5. I don't know. There could be a case made for maybe 1. I'm thinking closer to 0.5 though. So let's call it 0.5. And again, do y'all see how that works? If I go from x is 0.5 down to the graph, do you see that that's at about a depth of negative 2? So when x is 0.5, y is negative 2. And that one's so important. Let's do another one, okay? So f of x is negative 3 when x equals what? 2. And again, does everybody see how we get that? What does f of x mean? Y. So this says y equals negative 3. So that means I'm going to go on the y-axis down to negative 3, and then I'm going to go over until I hit the graph, and I'm going to see where that is. And that lines up with a 2 on the x. So now do y'all see the relationship between part C and part D and E? One of them says when x is a number, find y. And the other one says when y is a number, find x. And it's a lot like reading a map. A lot like reading a map, you know? If I go down to 2nd Street, you know, how far is it down to the grocery store or something? Okay, never mind. It's a lot like that. And are y'all ready for the next problem? Number 8. All right, so we're going to do the same thing we just did with a different graph, answering all the same questions. Different graph, though. And so now we're going to have to find the domain of a parabola. Oh, it's got arrows this time. That makes a difference.
Negative infinity, positive.
Now, let me ask you a question. Do you see this parabola opens down? Will it go down forever? Because of the arrows. But as it goes down, it also widens. So if it goes down forever, will it spread out forever? And will it cover the entire range of x's? And so that means x can be anything. Another way to say this, you could say the domain is all real numbers. That's another way to say that, all real numbers. Is the range also all real numbers? No.
It's negative infinity, it's 4.
And what symbol should that 4 get? Bracket. Now, did y'all hear me say that the range has to go from bottom to top? So then my first question would be, how low does it go? This is like graph limbo. How low does it go? All the way down to minus infinity, but does it go up forever? No, it maxes out at, and do you know why it's a bracket? Because that point is included. It actually touches and is included. Part C. Let's do f of 0 this time. What is f of 0? And again, do you understand that this says when x is 0, what's y? When x is 0, y is up at 4, okay? Okay, let's do another one just for fun. What is f of 1? So f of 1 appears to be about 3. Again, do y'all see how that works? When x is 1, you're going to go up till you hit the graph and see how high that is. Yes or no? Okay, now for part D, f of x is 0 when x equals what? Negative 2 and 2. F of x is 0 at 2 places. Everybody see that one? Again, what letter does f of x represent? And if y equals 0, that has to be on the x-axis. Every y coordinate on the x-axis is 0. And so the graph touches at negative 2 and 2 on the x-axis. And now have y'all got that? Yeah, go ahead.
Will this be on the test too?
No. And the reason is because I've already done the test review. And so if you didn't see it yesterday, it won't be on the test. Are y'all ready to move on to the next new thing? Number 9. Number 9. We have f of x equals 2 over x plus 3. And the instructions say find the domain. Now, it would be really nice if you could tell me what kind of function that is. It has a name. What kind of function is that? What did you say? It was coming out right.
Radical?
No. Rational. It was coming out right, though. You were like, and I was like, yeah, no. Yeah, this is rational because it has a fraction with a letter in the bottom. What would it have to be a radical function?
The thing.
Oh,
Yeah, you're giving me the sign language.
Yeah.
The thing. The square root.
Square root, yeah.
Or cube root.
Okay.
Or fourth root. Or fifth root. All of those are radicals, okay? But this is rational because it's got a fraction with the letter in the bottom, and we're asked to find the domain, okay? So, remember the domain are the values that x can be, right? Is there any number here that x can't be? Is there any number that x can't be? Huh? Negative 3.
Because it can't equal, the bottom can't equal 0.
Right. Okay, so let's start from the top, okay? From the beginning. Does a rational function have a restriction?
Yes.
Yes. What can the denominator never be? 0. So since there's a restriction, and that says that the denominator cannot be 0, then we're going to be able to solve for x and find out what x can't be. So moving that over, we know that x cannot be negative 3. Is that the only number x cannot be? Yes. Any other number that I plug in for x is going to be able to work out and give me an answer, okay? This is the only restriction. Now we need to turn that into the domain. Now, would you like set notation or interval notation or both? You're going to get them both anyway, yeah. All right, so here we go. First, are y'all watching? The set of all x such that x cannot be negative 3. This is set notation. And did y'all see how freaking easy that was if you know the restriction? If you know the restriction, you just put the other fancy stuff on there and you got your domain. Now, let's look at that with interval notation, okay? Are you ready? Now, I'm going to ask you a question before I do it. Can x be any number but negative 3? Yes. And so the way we say that, we say x can be anything from minus infinity all the way up to minus 3, but not including negative 3, or anything on the other side of negative 3 to infinity. And that is interval notation. And again, do you see how that shows that x can be anything but negative 3? See what it's, look, minus anything, minus infinity up to negative 3, skip over negative 3 and keep going. Up to, skip negative 3 itself and keep going. Questions? Yeah. Would you like to do a radical function? Would you like to try one of those? Okay. I'm going to have to make it up because there's not one in the book like it. All right, we'll try that one. And then after we finish this problem, we're going to have to go on and do number 23 also. Okay, so looking at my problem, the g of x function, what kind of function is that? Radical. Oh, it's radical, dude, right? It's got a radical symbol. That's what this little this and this is, the radical. But specifically, it is a square root. Y'all understand radical is a global term? Square root is a specific term, okay? Does a square root have a restriction? And the answer is yes. What can the stuff under the square root not be? Negative. And so we know that the stuff under the square root has to be positive. And this is the way you say that. You say whatever is under the square root has to be greater than or equal to 0 because it has to be positive. And then if I solve that for x, I'll know what x has to be. 3x greater than or equal to 4. Divide both sides by 3. X is greater than or equal to 4/3. That is the restriction. If you're going to plug in a number and expect to get an answer, that number is going to have to be greater than or equal to 4/3. Now that is not the domain, that's the restriction. How do I write it as the domain? Well, we're going to say the set of all x such that x is greater than or equal to -3. And what notation is that? That is set notation. I would also like to have that in interval notation. Okay? So if x has to be greater than or equal to 4/3, how would I describe that with interval notation?
Bracket, 4/3, and then comma infinity.
Yay. And an infinity always gets a parenthesis. And do y'all see how that says everything from 4/3 and bigger? Greater than or equal to 4/3. And that again, that is interval notation. Are y'all ready for number 23? All right, here we go. G of x. Got another g of x. All right, so what kind of function is that? It's quadratic. Now that's a specific term, okay? There's a more generic term that I would have accepted too. Specifically, it's a quadratic, but in general, it's starts with a P, polynomial. In general, it's a polynomial. Y'all know what polynomial means? Many terms. It's got many terms. But since it's got an x squared specifically, that makes it quadratic. Y'all understand what I'm saying? I'm trying to get you used to these terminology. Y'all know why you need to know that, right? Because if, like for example, if my wife sent me to Walmart and she said, go pick up a polynomial, and I come back with a quadratic and she says, well, I wanted a cubic. And I said, well, this is polynomial, it's what you said. You didn't specify cubic. You know what I'm saying? You need to, never mind. You need to know how to use the right terms if you want to get the right thing, okay? So my question is, does a polynomial function have a restriction? Does a polynomial function have a restriction? No, is correct. Does a rational function have a restriction? Yeah, the denominator cannot be 0. Does a radical function have a restriction? Yeah, because we can't square root negative numbers. But a polynomial I can plug any number I want in for x, and my calculator will never give me an error message. I can plug in a negative number. I can plug in a positive. I can plug in 0. I can plug in pi. I can plug in anything I want, and this will work out and give me an answer. So what is the domain of any polynomial function? Yeah. And you were being awful timid about saying that, but that's correct. And I need to make sure that you heard what I said, okay? A polynomial function has no restriction. Therefore, the domain is all real numbers. And you did hear me say the global term, right? I didn't say quadratic, I said polynomial. So what if it was a cubic and they asked for the domain? Our numbers. What if it was a quartic? Have y'all gone through the names of all the... We should do that real quick, okay? Yeah, let's just go through the names, okay? All right, so what if I have g of x equals 3x minus 4? What would we call that function? It's polynomial is the general term. What's the specific term? Okay, binomial is a good word, but it doesn't describe what type of function it is. It tells me I've got two terms, but it doesn't describe the... In other words, it doesn't tell me the degree of the polynomial. The degree is the biggest power. So what is the biggest power in this problem? And what do we call those? Starts with an L. Isn't it y equals mx plus b? Yeah, that's linear. Okay, I'm so glad y'all came just for that today. What if I have 3x squared minus 4? Now what's the biggest power? And we call those? Now you're afraid to answer. Even if you know the right answer, you're afraid to answer. What is that? Quadratic. What if I have 2x to the third minus 5x? What's the biggest power? And what do we call those? And if you're wondering when is this going to stop, it's going to stop when we get to my favorite one. One of these is my favorite, okay? So what do we call x to the fourth? And you know how to remember that one? I think of milk. How many quarts make a gallon? 4. Quartic, right? 4 quarts make a gallon. 4 is quartic. Cubic. How about a Rubik's Cube? It's 3-dimensional, right? Okay, how about the next one? Let's go back to h of x equals x to the 5th minus 7x. Now the biggest exponent is 5. What do we call that? I hope I spelled it right. Quintic? Quintic? Somebody Google that real quick. Quintic. And my favorite. This one's my favorite.
I want to say, but I want to get it wrong, so I'm going to say.
What would be your guess?
I don't know.
Are you ready?
Yeah,
I'll give you the first 3 letters.
I know it.
How do you say that?
Sexy.
Yeah. Yeah, it's my sextic. That's a real term in math. All right, so I'm glad I went over that. That's where I'm going to stop my recording.